A particular region or regions as the solution set. Good day, everyone. Today, we will continue practicing our skills on solving quadratic inequalities. From the previous videos, you learned how to solve quadratic inequalities that have a solution set of all real numbers, a solution set of one point, or no possible solution. In this video, we will learn how to solve quadratic inequalities that have a particular region or particular regions as the solution set. We have two objectives. The first is to learn how to solve quadratic inequalities that have a particular region or particular regions as the solution set. And the second is to recall how to solve quadratic inequalities. So let's get started. The first example is x squared minus 18x plus 77 is less than 0. Let's follow the steps we learned from previous videos. First, we factor out the trinomial. What factors of x squared and 77 will add up to negative 18x? Yes, x minus 7 and x minus 11. Here's a tip for non-perfect square trinomials that have a equal to 1. You just simply need to look for factors of the last term that will add up to the number on the middle term. So, negative 11 plus negative 7 will give you a value of negative 18. Therefore, our inequality will become x minus 7 times x minus 11 is less than 0. Now, we have to use the zero factor property to obtain the critical points. So, x minus 7 equals 0 and x minus 11 equals 0. We isolate x by transposing negative 7 and negative 11 to the other side. Therefore, x equals 7 and x equals 11.
These are our critical points. Step 3 is wherein we have to mark the points on the number line, indicating the numbers that make each factor equal to 0. Our critical points are 7 and 11, and these are the numbers that we have to mark on the number line. Now it is time to construct the graph. From our critical point, draw a line going downwards. We have two critical points, so we have two lines going downward. This is to separate it into three regions. Now we add another line going downwards, not to add a region, but to add a column for the factors of the given inequality and to label the particular regions. Now we must obtain the signs. In order for you to obtain the sign, you must make use of the substitution method. But first, we must start with a particular region. Let us start with the region x is less than 7. That includes all numbers less than 7. In the first row, we see the factor x minus 7. We must substitute any number less than 7 into the factor in order for us to obtain the sign. 6 is a number less than 7, so we substitute it into the factor x minus 7, which would be read as 6 minus 7 after the substitution. 6 minus 7 is negative 1, and since it is a negative, that is our sign that must be put on the graph. Now, following the second row of the same particular region, we must substitute any number less than 7 into the factor x minus 11. Any number less than 7 that is subtracted by 11 would give us a negative result as well, making us place the negative sign. Now, we must obtain the sign for the last row of that particular region, which is x is less than 7. In order for us to obtain the sign for the last row, we must multiply the two signs in the first two rows. Negative times negative gives us a positive, meaning we place a positive in the last row of x is less than 7. We apply this method in obtaining the signs in all the other regions. In the other two regions, we apply the substitution method as well. After obtaining the signs, we must determine which particular region or regions would satisfy the given inequality. The particular region that is the solution set to the given inequality would be the middle region, which would be 7 is less than x less than 11. Because in that particular region, any number that is greater than 7 but less than 11 would give us a negative when plugged into the given inequality. In the given inequality, it is said that it is less than 0, and anything less than 0 is negative, and that satisfies the given inequality. Since a solution set is an ordered pair to make an equation true, in this case, it is a particular region or regions in which it would make the given inequality true. To write the final answer, the solution would look like open brace x such that 7 less than x less than 11 close brace. Great job! Let's get started on the other example. 4x squared minus 8x minus 32 is greater than 0. Let us proceed with the first step. Let us factor the general trinomial. When factored out, we would get 2x plus 4 times 2x minus 8. Continuing, we must use the zero factor property to obtain the critical points to be marked on the number line. Let us begin with 2x plus 4 equal 0. We must isolate the x by transposing 4, which would give us 2x equals negative 4. However, as you can see, x isn't completely alone. It is read as 2x. In order for us to cancel that out, we must divide both sides with 2, which would cancel out the 2 right beside the x. Upon dividing it, we would get x equals negative 2, since negative 4 divided by 2 would give us negative 2. Following with the second factor, which we must equate with 0, we get 2x minus 8 equals 0. We must isolate the x and transpose 8 to the other side. We must divide both sides by 2 in order for x to be completely alone. And upon dividing it, we would get x equals to 4. These are our critical points. Following with the third step, we must mark the points, which are our critical points, on the number line, indicating the numbers that make each factor equal to 0. The marked points on the number line are negative 2 and 4. Like in the previous example, we must make our graph, following from the marked points on the number line, dividing it into 3 regions, and adding a column for our factors. Now, let us get the signs for our table. In order for us to get our signs, we must start with a particular region. Let us start with x is lesser than negative 2. On the first row, you can see the factor of the given inequality, 2x plus 4. We must substitute it with any number lesser than negative 2. And we must apply it with the method of substitution into the factor 2x plus 4. Let us choose negative 3. 2 times negative 3 plus 4 would equal to negative 2, which is a negative value, making us place a negative in the first row of that particular region. Now, we must obtain the sign for the second row of the region x is lesser than negative 2. We must obtain any number that is less than negative 2 and substitute it into 2x minus 8. Let us use negative 3 again. 2 times negative 3 minus 8 equals to negative 14, which is a negative value and gives us a negative sign to be put in the table of the second row of that particular region. Now, we must multiply the signs of the first 2 rows in order for us to get the sign for the last row. We would get positive, since negative times negative is positive. We apply this with the other regions in the table in order for us to obtain the signs. What region or regions do you think is the solution set to the given inequality? Well, the region or regions that satisfy the inequality is x is lesser than negative 2 and x is greater than 4. Because a positive value satisfies the condition in which inequality is greater than 0. To write the final answer, the solution would look like open brace x such that x is lesser than -2 and x is greater than 4, close brace. Synthesis. The number line is used to determine the particular region or regions as a solution set to the given inequality. The term equal is not used, however, the term such that is used in the solution set. First step, factor out the inequality. Second step, apply the zero factor property. Third step, mark the critical points on the number line. The fourth, construct the graph using the critical points. Obtain the signs using substitution. Sixth, determine which sign from the particular region proves true for the given inequality. And the seventh step is to write the solution set. Thank you so much, and we hope you have a lovely day.